Hello, how are you, my friend? Yes, today I'm back with a Mastercam video, so I'm not gonna make a video on tooling anymore, maybe someday in the future. Okay, and now I'm back with the Mastercam. Alright, as you can see, in the past week I have made some tutorial on programming the Titan of CNC part. Yeah, maybe I make 2 or 3 part, but after that I got an email from the Titan CNC, and they told me that I violate the term and conditions, and they asked me to put down all of the video using their solid. So I have to put them out. I don't want to get in trouble with this. uh, that's quite sad. So I make another video, so I'm not uh, going to use that solid anymore. Okay, and okay, back with our part today. I want to show you a case study where we can use the for you who are interested in multi-axis. And this video today is a case study. We will use the multi-axis toolpath to machine to finish machine the inside of this part. I don't know what this part called, maybe a car part. I got this from one of my friend. He living in Florida, and he make custom part for car. So yeah, I asked him for permission for using his solid to make my tutorial, and he agreed. So that's good. um, the shop here, R&G Manufacturing. You can find him on the Facebook, RGM Manufacturing, and he make a custom part for your car. Very nice. So if you're interested, just contact him. He's living in I don't know how to read it. He's Florida. Okay. Okay, thank Barbie for the good model, and so I use this for this case study. And the case study today is, you can see this quite big part for the regular machine. I will oh, what the hell, sorry, this the recording software does not allow me to use the hotkey to measure, so I need to measure it manually. Where is it? Okay, analyze distance, and this is our part. You can see the distance from the top to the bottom is around okay, yeah, about 3.5 inch. So the case is, you only have a small tool. For example, you can see we have some small corner here. I will check the corner also. Yeah, use the dynamic. You can see the diameter is only 0.5 inch. For some part that this radius is not important, you can use a bigger tool, so you can reach to the bottom of the part with no problem. But if in some part the corner radius is important, so you have to use the small tool to machine this corner. So the problem is with the small tool and with the long distance. You can see from top to bottom is 3.5 inch. So the tool would be very long, and it cause a lot of chatter. That's what you don't want, because if you have chatter, the surface finish will be very bad. So everyone know that. And our powerful tool is, we have a multi-axis machine. Yeah, and with a multi-action machine, you can use a short tool, more rigid, but you can tilt the tool axis, so you can move to the bottom of the park without collide with the park wall and other part of other area of the park. So that's what the multi-action machine bring to you. Very good property. So in this case study, I'm gonna show you how we can use a multi-axis toolpath to machine this inside area of this park. Okay, for example, we have do the roughing, or we already do the roughing on the roughing, and we just do the finishing. Okay, and for example, we only have the half inch end mill, so half inch ball mill. So we will use the half inch ball mill to machine this part. You can have other option like you use a very big tool with the length enough, and you finish cutting the surface inside, and after that you just use the half inch ball mill to do the resting finish at the corner here. Yeah, that's your choice, no problem. But this is a case study, and I'm gonna show you how we can use a small tool with a short with a cutting length, very short cutting length, and we can cut into the bottom by tilting the axis. Okay, this model you can see I will mark the surface we want to machine so you can easy to see. Alright, let me check. Ting 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 ting. Okay, we can change the face. I like the green color, so I like the green, so I will pick this color. Okay, and then we select the face you want to change. Okay, I will finish the wall of the park using a multi-axis toolpath. Okay. Alright, now it's easier to see. You can see that the green surfaces is the surfaces we want to machine with the half inch ball mill. Okay, and if we have a smooth toolpath, the first thing we have to process, we have to make some modification to the surface. Okay, this part we have two big hole here, and if you lift the hole here, you don't gonna have a smooth toolpath. So you have to fix that. You have to patch the hole here. Okay, you have to fill it. If you already make the toolpath using this solid, if you change it, you will lose the hole. So you have more than one way to modify the model. The first thing, you make no change to the solid, you just create surface for machining. Okay, and the second, I copy this model to another one. Maybe I go 10 inches, and then I make modification on the right solid here. After make the modification, I copy it back to the original location, and I will do the finishing using this solid, and I will keep this solid for other toolpaths. Yeah, this is another option. Okay, you can use the model prep function here. I have another video showing how you to fix the hole like this easily. You can use the moving to push the hole out of the part. I will try to use if it work or not. Okay, we select the surface and we move it outside. Yeah, you can see, very easy. Yes, very easy. Okay, oh sorry. And we do the same with this one. Now I will try another option like a modify feature. Okay, I select the face. Okay, and this chamfer, and I select remove, and I click enter. Shoo! Okay, it disappear. Perfect, right? Very cool. And we keep the original solid, and we will do the multi-axis toolpath on this solid. Okay, you can put it in onto another level, like maybe F99, and I name it at another name, like how to name it, what name, maybe clone, I don't know if I right, maybe brother. Yeah, I named the name brother. I named this solid brother. I moved to the level 99. Okay, and this is the brother, this is the original part, and this is its brother. After that, I move it back to the original location by using the move option. Okay, now it will be minus 10 inches. Alright, and now you can see the original part and the brother and its brother is the same location, so you can turn off the solid part to make sure you don't work anything on this, and so the other toolpath, if you have created, will not be effect. So that's cool. You're just working on the product part. Okay, yeah, that's it. One option that we use the model prep function here to modify the solid, and we create a smooth surface like this, so it will be easy to create a smooth toolpath. Okay, and the second option, you can work on the solid part here, the original part. You don't need to create its brother, you don't need to create this, you just create the surface. Okay, we don't machine using solid model, we will create the surfaces to be machine. Okay, to do that, okay, I will create another level. I call 100. Okay, this already created, maybe 10. Okay, and I name it multi-axis surfaces. Okay, so we create a new level for the surfaces we created. Okay, we move to the surface and we select a surface from solid, and I'll create this surface, this. Okay, we create all the surface we want to machine. Okay, and ping. Okay, ping. Now you see that we have the surfaces. Okay, and we also have to fill the hole here. You have many ways to do that. You can use untrimmed surface, or you can use the remove boundary here. Click on the surface, move around to the whole edge. Pew! Yes, beautiful. And pew! Yeah, very easy. But the surface is go extend a little bit, so maybe this not a good option. We don't want to keep it. We delete this one, and we use the same for this surface. Okay, try with this. It's not good. If it's not good, just remove it. Okay, we turn on the solid part again. So we have to find another way to create this surface. For this one, you can use the sweep. Okay, sweep surface. Okay, you can create a curve here on the solid edge. I have the curve here. I make a curve here. Okay, and I move this one. Move here, from here, and move it to here. Okay, and I'm gonna make a sweep surface using this curve and this curve. Very simple. I'll show you. Okay, surface, and we go sweep. Okay, activate a single selection. Now we have to select a cross contour. Select this one and click on the apply. Now we have to select the along contour. We select this one. Okay, So very easy, because this field is very easy to create it. So very no problem. Okay, we can use the rotate or the translate will go like this, and maybe the rotate option is a good one. So okay, we have created a good surface. Okay, we can do the same with the one on the right, or you can use a mirror. Okay, mirror with a mirror. Okay, we can select mirror. Choo. Okay, very simple. Now I will turn off the solid. Okay, we get smooth surfaces, so we don't need to make another copy of a solid. We just create a surface and we can machine using these surfaces we created. Okay, alright, we hide the solid. There's one thing here, you can see I want a surface here to be smooth. I want to use the morph toolpath to machine this fillet. So I want this surface is continuous, so I want to split this surface. I don't want it to be like this. You can see I want it to be split at this location display, so we have a continuous surface from here to here, and we split this surface at this position. Okay, to do that you have many ways also. I will show you a way to do that. We create a wireframe. Choo. Okay, and we create another one here. Choo. Okay, and we move it from here. We copy, move it from here. Ew. Okay, we hide the solid. We delete the original surface. So we have one curve here, and go to the surface, and I use the loft. Okay, we select this one, ping. Oh, sorry, only this one, and we loft it, another surface. Okay, we create another one using this curve and this curve. We're using the loft rule and loft, and we have another surface. Very easy. Yeah, you have many ways to do that. You can split the original surface, no problem. Any method you can choose yourself, no problem with me. Okay, so now we have the surface split here, and we have a continuous set of surfaces, so it's easy to create a toolpath. We can use another option to split it, or just simple you can mirror this surface and this surface from the x-axis, then you get the set from here. But I will show you how we can split the surface. Okay, we create a curve here and move it from here. Okay, and move it from here to here. Okay, we can hide the solid. And now we use this curve to trim the surface. But if you want to trim the surface, the curve must be closed, so I need to create sorry, I want to create a closed curve, so I can split the surface. Okay, we go to the surface again, and we can select trim to curve here, select the surface and click enter, and then we select the closed curve here and click apply. So I can use the split model here, so the Mastercam will keep the both surfaces, so it does not remove any surface. Click on this, move around any position you want, and click again. Oh shit, we should select normal. Okay, reselect the surface, we select the normal projection, split model, click on there. Okay, it's done. So you can see I split the surface, split 1 into 2. Okay, you can keep the curve if you want, you can use it later. Now you can see I have two set of surface. This is the first set. I will mark it. I'm gonna mark it with maybe the green. Yeah, I love the green color. And the upper I mark with the, oh sorry, you can see these surfaces they are not mirror, so you need to other step if you want to use a mirror option. Okay, you can see we have a two set of surfaces. The first one in the fillet at the bottom is marked at green, and the upper set is the wall of the park, so I mark it as orange. So okay, we have a good preparation on the park. Okay, it's just to make sure you have a smooth toolpath, not so many rejection. That's what we don't want. Okay, the smooth toolpath make a smooth surface finish. Yeah, okay, so let's check what the tool we have. I can check if what tool my friend give to me. Okay, I have a 1/2 inch ball mill. I will remove the other one, so we can only have one. Okay, for example, I only have a 2 inches, maybe, yeah, 2 inches overall length. Okay, and you can see the distance from here to here is more than 3 inches, so we got a problem if we use the soft tool, so we need to tilt the tool axis. Okay, you can select many tool paths to machine this setup surfaces, so I just show you one so you can use. That's the one we have already talked about in another video. This is the morph tool path. Okay, this is the morph tool path. You can use the other tool path because this is not complicated surfaces, so you can use any you want. Okay, so I will use two different tool paths in the orange. With the orange surfaces, I use the parallel, and the fillet here I will use the morph, so you can see. At first I need to create some curve. Okay, curve on edges, select all. Okay, and open it. Alright, okay, so you can see I have three curves here. I don't know why this is not connected. You can see the surface is not still so good, so we have to fix this gap. This is the simplest way. Just connect them if they are not connected. Okay, okay, maybe when I mirror the surface, this part is not aligned at the center, and when I mirror this surface it go far a little bit, but not problem. Okay, after we create a curve, we create a toolpath. We go to the toolpath tab here and we select so I can select a parallel toolpath, so it will create a toolpath that's parallel to a curve or surfaces. Oh, we have so many tools here because I don't filter it, so I thought it's already got away. Okay, I select the tool and check the holder. Okay, for example, we have this type of holder. And you can see we have already have the two curves, so I can select the toolpath and make the toolpath parallel to this curve, and in 3 axis it look like a waterline toolpath. You can select one or more curves if you want. In this case I select, oh, this is not connected, shit. Okay, only one is enough. And then we select the dry surface. We select the dry surfaces. Okay, you can mark this is the fastest way. Okay, and selection. Okay. Then I don't want to go too deep into the detail on everything here, because you know a multi-axis toolpath there's a lot of parameters you need to care about, but I just want to focus on some important parameter, and other parameter you need to figure out yourself that make you better. Okay. Yeah, alright. So here you can set the cut tolerance. If you set a small value, the toolpath it take longer to calculate, but you have a better surface finish. Okay. You can select the step over, for example, and maybe I don't know how to call it in English. Then you call it 200 or something. Not sure about it. Okay, because this is a closed surfaces, so we can select the one-way method. Okay. Alright. And the output format, you can select the 5 axis, and this is very important thing, that is the tool axis control. You can see with the multi-axis toolpath we have a lot of tool axis control strategy, so you need the important thing, you need to find one suitable for you. I think this toolpath is a toolpath from module work. This make a multi-axis for Mastercam, and there's a reference document on the website emastercam.com, so you can go to that website and download the module work documentation. They have a lot of information on the multi-axis toolpath, the tool axis control, and all the parameters, so you can make a reference. That's a good document. Okay, go to emastercam.com and download it. On this case, I'm gonna select a fixed angle to axis. You can see with every option Mastercam has a description, photo for you, description, image here, so maybe you know what does mean. Okay, I select the fixed angle to axis. Okay, oh sorry. That means you can select a fixed tilt angle for your tool axis with a axis line. You can select X, Y, or Z axis, or you can select a line for the axis. Okay, in this case, because the part is sit like this, so I can select a fixed angle to Z axis, so we can tilt an angle from the Z axis here. Okay, I can try 15 degree to see if it works. And if you want a tool axis to be cut the original axis here, you can select this option. The tool axis will cross the tilt axis. Okay. In this collision control, you have 4 status. For example, for the first status, you can select collision control with the fluid of the tool, and in the second, you can set another section of the tool, like the shank and the holder with other surface. Yeah. For example, I don't want the tool to gouge the part surface, so in the first status, I just check onto the fluid section of the tool, and I just want to check it the dry surfaces, so just make sure that the fluid did not cut through or make some collision with the dry surface. Okay, if the collision happen, you have many options to process here, to fix here, like trim and relink the tool path. You tilt the tool to avoid the collision. Okay. You can also set the collision control for the tool holder. Yeah. And normally with the tool holder, I can select the tilt tool option. So if there any collision with the holder or the shank of the tool, it will automatically tilt the tool axis. Yeah. We also have two options here: automatic tilting and change the fixed tilt angle. Yeah. Okay, and we can check it with the check surfaces. Maybe the top surface of the tool or the part. Okay, I will try it. We need to turn on the part and select this face at the check surface, so we want to make sure that the holder will not collide with this one. Okay, and see the tilt tool where the collision happened. Okay, stop to leave, no need to stop. Okay, and you in a plus, and you expand here, you can see there's some tilting option, and if you want to know what is it, just look in the reference document. I even don't know much about this. That's the truth, so you need to read the document. Okay, and if you already checked the shank and holder collision checking, you need to go to the tool clearance here, and you set the clearance for the holder and the shank of the tool. For example, I want to set a clearance of only 0.05 for the holder, and for the shaft is the shank of the tool. Yeah, when we have 0.01. Do you know how to read it in English in a professional way? I think this 100 or something. How do you read this? You can show me. I don't know how to read this number, 100 or something. I just read it, can read it like 0.01 or 0.05, and I think this is not professional. Okay, this linking parameter, you can use the lead in at the first entry and lead out at the final at the last cut. Okay, and for a small gap you can follow the surface, and don't use this in lead out. You can follow the surface, or you can use plain as spline. You need to try other option to see what that means. I cannot show you every one of this. Okay, if a lag gap happen, the tool will do go direct follow surface, or the tool will retract this like oh shit, oh, man, I just pressed escape button and everything go off. Shit. I need to create it again, damn it. Okay, select a tool again, let's make it fast. Shoo. Okay. Shit. Try surface. Okay. Damn it. Zigzag one way. 200. Okay. This is the try surface offset. If you want to leave stock for other operation, you can leave a value here, maybe 0.01, or if you want a finish cut, just leave it 0. Okay. Fixed angle to axis, Z axis, and tilt angle is 15 degree. Okay. Core control. The fluid we check with the dry surface. And the shank and the holder we check with the check surface. Okay, we select the check surface. We use the top of the part for the check. Ping, ping. Okay, and go to here. Okay, and set the maybe the clearance for the holder and clearance for the shank of the tool. Yes, this is the shoulder and this is the shank of the tool. Okay, you can select the clearance type like a cylindric or conical. If you select conical, you have two values to define the clearance. Okay, linking you lead in and you let out at the first entry and the last exit. So, and for the small gap, I just want to follow the surface. Okay, and for large gap, I will retract the tool to the clearance area. Okay, we can set the clearance area here maybe 2 inches. Okay, and this is we define the gaps like in a 3D toolpath. You have the gap distance and this like the gap distance. You can input maybe this is compared with the tool diameter in percent of the tool diameter. You can input a fixed value here, maybe 0.5 inch. Okay, expand this here. We have a default lead in and lead out. Check maybe 0.125, 0.125. We have many kind of approach here, but you can figure it yourself. It's many parameters. I can talk all the time because I even don't know all about them, so I don't. It's better I don't talk anymore about this. This is the one I use the most, the tangential arc. So it will create a tangent arc lead in and lead out. Okay, we also have other options like roughing. It allows you to make multiple depth of cut or multiple passes. Very useful when you want to do a roughing or semi-finish. Okay, maybe everything is okay. Okay, and we ping, then wait for calculation. I have this work. Maybe I can pause the video so you don't have to wait. Okay, it's done. You can see. You can see the tool need to. We look from the front. You can see the tool need to 15 degree from the z-axis. And I think that tilting is not for this holder. We don't need to tilt too much. Okay. And you can see this cut from the bottom to the top. You can see if it's does not collide at the bottom. So yeah, we can do a slower value, but I think 15 degree is okay. Yeah, if you want it to cut from the top to the bottom, you can check on here. We flip the step over, choo, and aim. Wait it. I can set a big value of step over so we don't have to wait too long. Okay. So you can see if we we flip the step over, it will cut from the bottom to the top. I can activate the tool and display the vector. Okay. So you can see this is a tool vector. That's good. Why we should use the multi-axis toolpath for this instead of using a 3-axis with a tilting option, because in my experience, when we use the tilting option in a 3-axis, the tool axis keep changing and it's not good. As when we use a true multi-axis toolpath, it's a better controlling the tool axis. You can see the tool axis is not changing error here, and if you use the tilting option in a 3-axis, sometimes the tool axis it keep changing and you cannot control it. With true multi-axis, you have more and more options to control the tooling axis, and you have a lot of check collision control, so it's easy. Okay, I will give it another case that, for example, if we only tilt 5 axis, okay, and we don't check, we don't use the collision control, let's see what happened. Okay, now I can hide the tool vector. Yes, okay, so you can see when the tool go down, we have some collision, yeah, with the holder. That's what we don't want, right? If we tilt only 5 degree, the holder we will collide with the park wall, and because we don't set any collision control, so nothing happened and the holder will collide with the park. If we activate this status and we check the collision with the holder and the sign of the tool, and we tilt the tool when the collision happen, you can see the this one. Choo. Ting ting ting. We have to wait, we have to wait, we have to wait. Okay, it's done. Now check it again. You can see when it go deeper, the tool axis is automatically tilting, so there is no collision with the check surface we have selected. Okay, yeah, that's the collision control and how it works. You can figure out more options when you read the document. Okay, and we can take a look on the tool axis. Okay, you can see this is a tool axis at the top, and when it go deeper, you can see that the tool axis change. It tilt more outward, so the tool holder is not collide with the check surface, and that's good, right? Good option. Okay, that's why we should use the collision control here. Okay, so that's the parallel toolpath multi-axis. It's like exactly like a waterline, but with the tilting option. I will hide the vector, and we can see if we had, you can see this is the lead in motion, and this is small gap. You can see it's follow the surface with this, and when I check another option, I will show you. Okay, this is the small gap, and if let me see, linking here, if we not the plane as beline, you can see the difference. I already talked about this in another video on the linking. Yeah, you can see from this slide to this slide, the small gap, and you can see this the spline transition. Yeah, so we have many options for this. This is the first lead in, and this is the last letter we use the lead in and lead out option. So okay, so we done for the first toolpath, and the second I will deal with the services in the bottom. Okay, now we use another toolpath. Tang 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 tang. Yeah, you can use the parallel for all surface here, no problem. This is up to you. I just want to show you a more toolpath, so you have more option later. Okay, now we use the morph toolpath to machine the the bottom fillet here. Okay, we use the same tool and cut bottom. You can use the curve to control the cut, or you can use the surface, no problem. Okay, now use the curve. I select the top curve here. Oh shit, I need to join the curve here. Okay, this is a quick way to fix it. Oh man, I need to fix this first. Okay, let's join it. Go use a line to fill the gap. Okay, fill the gap. Okay, do it again. Morph, select the tool and select the curve. We will morph from this curve to this curve. Okay, then we select the from curve we have select this one on the top, and two curve select this one at the bottom. Okay, and we select the try surfaces. We select the green surfaces here, and okay, so yeah, this is the surface we want to select. Yeah, you should select the surface between the from and the two curve here. You can see I have selected this curve and this curve, so we need to select the surface between the curve we selected. Okay, that's all for the curve and the surface. Also the cutting method, we go one way, cut torrent, step over, yeah, maybe any value you want. Okay, we use the same tool axis control in the last toolpath. Okay, fixed angle with axis, fixed angle to axis, and Z with maybe 10 degree enough. Or if you go deeper, you need to tilt more, maybe 15. I think it's not also. Okay. We do the same with the checking collision. We also can check this surface for checking, no problem. It's up to you. Okay. You listen and you lead out at first in the bottom cut. Plane as spline and return to the clearance area. Set the clearance here. Okay, and no roughing required. Okay, it's done. I just want to show you some important parameter as I told you before. Okay, let's check it out. And oh shit, what happened? I need to check if I select the surface. Hide this one. Surface change. Okay, we have problem here with the dry normal, the surface normal. You can see sometimes you have some weird problem, and sometimes it's caused by the surface normal. As I talked to you in another video, we have the normal of the surface. Yeah, and if you select in change and see if in light color like this, you can see we have this small surface. They have the different normal with the other surface, so we need to change this. Ping, yeah. When we change the surface normal, everything needs to go okay. By some reason, the normal of the surface is changing and is different with other surfaces, so the toolpath is not smooth and we have interruption here. So you just change the. Okay, very beautiful, very beautiful. because we use the tool close to the the fillet radius here, so we have something here not that good here. We can try to use the round corner to see if we can avoid the sharp edges. Round corner here, and maybe we round the corner. We set the radius value to avoid the sharp edge here when the tool come to the corner. Okay, we have many options with the multi-axis toolpath. Oh, that's not good. So I just show you to here. You need to figure out more options to make your toolpath look better. Okay. Damn. Okay, I tried it. If it doesn't work, you have to figure out yourself. I don't know how to fix this. Okay, wait a minute to see if any different. So when you select the dam, nothing happened. Maybe you need to select a smaller tool for the finish so you can avoid the sharp edge, the small corner here. Yeah, okay. Very simple. I'm gonna show you the difference when we use the true multi-axis toolpath with the 3-axis toolpath with tilting option. It's much different. Okay, waterline. Okay. Set the surface. Okay. Containment. Alright. Select a tool and the step over, step down. Okay, and yes, I think that's enough. Okay, you see, this is the waterline toolpath without the tilting option. The toolpath look good, but the tool is too sharp, and we need to activate the holder tilting option here, collision checking, and to avoid gout. I have some advice from the other guys. He say that this tilting option Mastercam they just make it not so good, not so article. So it may work in some simple cases, but in some difficult cases you should not use this option because it's not so good in controlling the tool axis. The tool axis can changing every time, so it's not good for the surface finish. Okay, I can try it to 15 degree. Okay, and see if we have any different. Okay, so if you can use the multi-axis toolpath, you should use it because you have more option and more way to control the tool axis. Also the collision checking. We need to weigh the calculation. Okay, and then just weigh. Okay, it's done. Let's try. And oh my god, what happened? Oh shit, you see that? It's even didn't tilt. Why? Why? Maybe I should select one surface here on the top. Oh, sometimes Mastercam go crazy. You don't know what happened. Okay, we waited again. No, what happened? Okay, we set the machine simulation. Oh shit. Let's see if I have some beautiful machine. And okay, the GMU geometry. Select element. Oh no, this one. Okay. Translate. 4 inches. Okay. Okay, it's done. And okay, now it tilt. You have to select the top surface here. That's crazy. Oh, it's look good, but it's not so good. You can see. Alright. Maybe we haven't tilted enough. I'm not sure, but so you can see a difference. This is when we use the 3-axis toolpath with the tilting option. Everything looks cool, but sometimes it go crazy. We check the vector. Oh, you can see. If we look at a vector, you can see sometimes the vector is not good because it's changing every time. That will not make a good surface finish. And when it go lower, you got some crazy thing like this. I think you should input a greater value here, so the retraction is gonna not happen. But if you can use the multi-axial toolpath, just use it because it will give a better toolpath and better control. Okay. Share. Okay. Now let's try the simulation. Oh shit, where the pop? Alright. Okay. Go. Turn the power. Okay, we go like this. There's another toolpath is very good. That's a 3 to 5x toolpath. I maybe when I have time I will talk about this next time. Yeah, cool. In cool, right? Toolpath. Follow. Yes. You can see there's not changing in the tool axis, so you can get a good surface finish. If you can see the rotating table, it keep rotating. That means you're gonna have a bad surface finish. Yeah, at least it's not good. If it's not bad, it's not so good. Okay. You. All right. It's work like a champ, right? Yeah, it's go crazy. When it go to the corner, you see? When it go to the corner here, the tilting table will rotating. Okay, but when it cut to the smooth area here, no changing in the tilting table here. only this table working. That's a good sign, right? So in this video I just show you a very simple case study in a multi-axis toolpath. Yeah, when we work we may have a lot of more complicated case, so the only way you need to practice many times. So yeah, this just a simple case, and it gives you the standard knowledge. Yeah, and when you work and you face some more and more difficult part, you can figure out some other cutting strategy, and yeah, they provide you a good, a better control in the toolpath. Okay, I hope this video can help you. Okay, yeah, maybe yeah, we stop here. Thanks for watching and goodbye for now. See you again in the next video. Okay, I am finding the emergency stop. Where is it? Emergency stop. Phew. Okay, goodbye.